Hello everyone, this is Shrikant. Welcome your new channel of fluid mechanics. In this lecture series, we are going to discuss everything about fluid mechanics in interesting and simple way. So yes, for this in an introductory lecture, we are going to discuss the basics and fundamentals of fluid mechanics, which is introductory part, which is very interesting. If you like this video, please comment and share it. So what is fluid? Fluid is a substance which deforms continuously under the action of shear force. And as we know, fluid is liquid plus gas, or it is either liquid or gas. Mechanics is a study at rest or in motion. So we are going to deal with study of fluid at rest or in motion and its interaction with the different boundaries. So we'll discuss now very interesting basic fundamental properties of the fluid. So first, what is viscosity? Viscosity is the resistance offered by one layer of a fluid over another. So if you distinguish between water and the honey, that's the property, viscosity. So here you can see on the right side, you can see three different containers having three different liquids. So when a marble throw inside the three different containers, it will take a slightly different time for all these three cases. Why? Because resistance for honey and water is different. So that's interesting property called as viscosity, resistance offered by one layer of fluid over another. Next very important is a Pascal's law, which is very interesting phenomenon which is used for hydraulic lifts, hydraulic press. What Pascal's state about its law? Pressure is equally transmitted when it is inside a closed container. So here you can see a two example approximately meaning is same. When a small force is applied on the one end, that can be transmitted to lift a large object. So that is hydraulic jack. So we are going to discuss Pascal's law, its applications and numericals on it. Next, a very basic element of fluid mechanics is a mercury. Very interesting metal. That is, we can say it's as a transition metal, which is normally in a liquid form at room temperature, and its very important property is the density or specific gravity. The density of mercury is 13,600 kg per meter cube. So you might be knowing this diagram, that is the simple YouTube manometer. Mostly yeah, it is used for finding out the pressure flowing throughout the pipe. It may be gas or it may be liquid. So we are going to deal with this kind of very simple numerical on calculation of a pressure. Next, you know this capillary action from your 12th physics, very simple interesting phenomenon, rise or fall of liquid level inside a narrow spaces without support of any external forces. So that's a capillary action. There are a lot of example of capillary action you might be knowing. So we are going to deal with the capillary action also. And very important next term is again surface tension. In short, surface, water surface or liquid fluid surface tension. You can see these three images, videos. You can understand what is the meaning of surface tension. It is the tension exerted by a surface, or in short, it is a resistance offered by the surface of a fluid. That's why this insect can walk on this water surface. Similarly, this pin can stay on this water surface, as well as this color combination you can see on the water surface only because the resistance offered on the top face of a fluid. So this interesting phenomenon we are going to learn with the simple numerical on it. After this few basic term, we are going to learn types of flows. As we are dealing with the fluid, there are different types of flows for the fluid. Basic category, laminar and the turbulent. Laminar, streamline, straight and smooth flow, which you can see in this diagram right side. Water flowing through the tap, it's a smooth flow of water, that's a laminar. Turbulent flow is zigzag flow of water. Similarly, on left side you can see the smoke. At the bottom or the base, it is a completely a smooth, straight flow of a smoke. So that's why it is, we can say, the lower portion of the smoke is laminar. It's a streamlined, straight, smooth flow. Whereas upper part is zigzag. We cannot predict. So that is turbulent flow. Very interesting. So in this, we are going to deal with the types of flow, how to classify, and the simple numerical on it. Next part of our lecture series will be flow through pipes. So in a confined space, when fluid flows, so there are a lot of parameters which we are going to discuss in this session, that is flow through pipes. There are devices which are used to find out velocity across particular section. Again, there are different numericals to find out pressure, velocity, as well as the pressure head. So we'll be dealing with some kind of numerical. Again, they are very simple and very interesting. So devices and their numericals will be the part of our next lecture sessions. So which is interesting. Last, very important, which you can say the heart of fluid mechanics, is this continuity and Bernoulli's equation. You may scare because of some equation, but don't worry, it's very interesting and very simple. We'll find only two equations, this continuity equations and Bernoulli, and they are based on basics energy conservation principle. Total energy remains constant. So here you can see the section 1 and section 2. It's a pipe of changed cross section. So at 1 you can say the diameter is d1, velocity, and the pressure is p1. So at section 2 diameter is reduced. So accordingly P2 and D2, you can identify this parameter by using some continuity equation, and we'll be having some numerical on this topic. So in Bernoulli's equation, this pressure head, velocity head, potential head at two different sections is constant, and this equation we are going to apply for solving some numerical, which is very interesting and real life based, so that you can relate this example. So we'll discuss some examples of Bernoulli's. So you might have seen this kind of see. In garden, you might have seen a pipe hose which is flowing water. Sometimes, if the water pressure is not sufficient, so we may apply our thumb to increase the pressure of water. So that is, we are going to discuss how it is related with the Bernoulli's principle. Same. This fireman is spreading water at high velocity. So we are going to deal with some interesting numericals where we need to find out velocity, pressure head, and the dimension of this pipe. So this is very interesting applications of Bernoulli principle. Same applications of this Bernoulli's continuity equations. Upper diagram is like it's a ball. When it is spent, when a bowler throws that, this high pressure air and the slow pressure, how it creates the lift to the ball, which we normally call as a spinning of ball. So this we are going to discuss as application. And the same, when this truck is moving and it is stationary, this top face is flat when it is stationary, and when it is moving, that top face bulges outward. So why it happens and how we can relate this with the Bernoulli's equation, that's interesting applications. So I hope you guys like this video. If you like this, please comment, subscribe, and share it. Thank you.